Yeah, good afternoon, everyone, and welcome back to the session on your security topic. And today we are going to discuss about something related to your cryptography here. So, cryptography is the only tool what we have in order to provide security with respect to the data, whatever we are storing here, and whatever the data we are exactly transmitting over the network. This is only one of the technique what has been provided here, and this is the one which is mostly used in every aspects of transmission of data over the network. Since we in the previous session we have already discussed about the differences between a protection, and we also discussed about the difference between protection and security, right? So what do you mean by protection in the sense here is nothing but assume that we do have a laptop here, and that laptop is not connected to a system. I mean, sorry, internet. That laptop is not connected to this particular internet, and whatever the data is present in this particular laptop, we need to protect it from what? So the different type of viruses that may be infecting this particular laptop due to the external sources, something like you people can assume that as something your pen drive, or you people might be integrating another hardware devices, something like external disk. So these are some of the portable devices, whatever we are having, which we may be connecting to our laptop. So at that time, we need to protect the data that is present in this particular laptop. So there is a possibility that this particular pen drive you might have used or integrated this with different devices. Some like you people might have used in your lab, and you know that within the lab you might be having virus within your system, and that virus will enter in your pen drive. And when you're connecting this to your laptop, laptop automatically, so whatever the data is present, that will be started corrupting due to the virus, whichever is present in this pen drive, it will automatically will be coming and infecting your system. So we need to protect the data, whatever is present within this particular laptop. That is what we call it as protection. And remember, that is not connected with the internet connection. Internet in the sense nothing but there is no attack from the outside network. That's why we are talking about internet here. But if you talk about something called as security, what we were discussing, security is something like providing protection with respect to the resources that are present within the system and at the same time outside the system. We need to provide out for security with respect to outside the system. That is nothing but you people are now getting connected with the help of internet to the outer world. Outer world in the sense nothing but uh, just getting connected to the networks, and you people are transmitting the data. So whenever you turn on your mobile data, or you people are just connecting a modem to your system, it may be any kind of device, maybe your phone, maybe your laptop or anything. That means that you're totally exposed to the outer world. How? With the help of this particular networks. And we already discussed every device will have its own IP address. So using this address, if any other outside, the third person knows this particular IP address, he may try to attack on your system using different means. And that we have seen it, something we discussed about virus, we discussed about worms, right? We discussed about other different type of things which can be used in order to attack it. Okay, something we call it as Trojan horse. So these are some of the attacks which can be take place via internet. Remember that this is via network, not with respect to something called as your pen drive or something like that. For that, we are providing security. So now the question is that how we can provide, what are the different tools we have that we can use in order to protect the system from whenever it is connected to the outside world. That is nothing but the networks. So yeah, the best tool what we have till date from the beginning is something we call it as cryptography. Cryptography is the only tool which we are using right from the beginning. So let's go ahead and see what exactly it will consist of. So today we are going to discuss about this something called as cryptography as a security tool, and then what are the different things we have with respect to this particular thing. Now, if you ask me about security here in this particular thing, cryptography is the one which is used. Cryptography is actually the one which is used for transmitting the messages. And now, as I told you, that cryptography is the only tool we are using it. So we can say this is one of the broadest tool. Why it is broadest? Because most of the research work has been done on this particular format. Whatever the format you people are seeing here, all the research work is done on this particular concept called as cryptography. We have different organizations here. We have something called as NIST, National Institute of Standards and Technology. We call it as National Institute of standard and technology. So they are the one who actually has developed this particular cryptography. They are the one who actually develop new different type of technologies which can be standardized all over the world and which can be used throughout the entire world. So this is one of the organization. Like this, we have different organizations also, but this is the most popular among all the organizations what we are having. So here the tool what we are talking about here is nothing but cryptography, and this is one of the broadest tool what we are exactly having. Um, Here whenever you people are actually transmitting, so what exactly this particular thing or this particular cryptography is going to do is this particular thing is used to send transmissions. Okay, it is actually used for transmission of data. Transmission of data over what? Over network. For example, you wanted to send a Gmail, you try to send a Gmail to your friend. So how you can transmit that particular Gmail? Definitely you people have to give something like to address, then you have something like CC, BCC, and after that you people have a subject, right? And after that you'll be having some content to write, and then finally attachments. If you want to attach any file, you can do it. And once you click on a send button, whatever the data is present in this, it will automatically deliver to the destination address whichever you're giving. And definitely how it is possible to transmit it, definitely there should be an internet connection. If you don't have an internet connection, is it possible to send a mail or something like that? It's not possible. So that is what he's exactly saying here. So here in this particular thing, let me show you up once. Yeah. So here, what he is exactly saying is that whatever the computer we are having, that will be from where you people are transmitting the data. We will call that as a source, and the message will be reaching to your friend's system, right? It may be a mobile phone or it can be your laptop. That is what we are calling it as destination. Now here, whatever the data you're transmitting from one particular computer, I assume that this is a source computer, this is a destination computer. This is a source, this is destination. From here you wanted to transmit some data through here. So definitely what is this part? This is the one which is we call it as open network. This is what we call it as open network. Means anyone can try to come in between and they can try to hack the information what is present through which we are transmitting the network, because that is an open source. It's an open network. Anyone can come in between. So here whatever the data you're transmitting, we should make sure that whatever the information we are transmitting, that is secured and it is securely reaching to the destination. Suppose you people are sending hi, how are you? The same message should be transmitted here in the format of the way you are written hi, how are you? Something like this. Okay, so for that purpose, we are using cryptography. Now, what exactly this cryptography means here is nothing but, in simple terms, what I can say is, suppose as I told you that I'll be sending a message, hi, how are you? Right? Now, let us suppose you people are transmitting this on a WhatsApp to your friend. Now your destination means whoever the friend is, she will also get the same, or he will also get the same message. Hi, how are you? Fine, that's fine. Whatever you have transmitted, that is only has been delivered to the destination. But in between where it is traveling in the air, in between it is traveling in the air, in for this purpose, what they are going to do, so that the third person should not try to access the information, whatever the message you people have typed here, like hi, how are you, this will be encoded. This will be I mean this will be encoded using some kind of techniques, and the techniques I'll discuss. Okay, don't worry, in the coming slides we'll be discussing that. So here using some techniques here, I will be encoding the data and then I will be transmitting that over the network. So what will happen here? So whatever the data you people are transmitting over the network, that will be not this message hi, how are you? No, that will be something like just a normal, a rough estimate I'm giving here. Something it will be like F G K H A B C Z A K, something like this. Even for the question mark also you will be having something like 0. So this is a message which will be transmitted over the network. Can you read this particular code? I mean, read this message. What exactly? This is the same thing what I have written. Hi, how are you? This is also hi, how are you? But only difference here is when it is transmitted over the network, it will be encrypted in this particular format. Okay, so they will be using some encoding technique here. some encoded technique we are going to use, and using that technique we will be converting that message into this format, and one by one we'll be transmitting it, so that if a third person try to access the information, he will get this information. Now since he got this information, he will not be able to read the actual message, because to decode again this message has to be decoded. So to decode that message again, we require something called as a term called as a key. That key is what we call it as a secret key. Okay, so if you people are having this key, only that person can try to what we call decode this particular message. One more example what I can do you, the best practical example is your WhatsApp. I don't know how many of you have opened that particular WhatsApp with respect to your friend. You will say that the security code has been changed with your friend's number. Did you see there will be a hologram? There will be a hologram there, and there you will be seeing that the security, if there is a security code changes, this hologram will also change. This is the hologram. This is the key, you can say. This is the only key which is present in between you and your friend. So whenever you're transmitting any message, so that key will be used within your system. That key is used to encrypt the data and send it up. And when it reaches your, so I mean your friend, she will be having the same key, and using that key, she will be decrypting the data, and finally she will get the actual message. Now in between, suppose a third person comes and he tries to get the information, he will be definitely getting this particular information, hacked information. So this encoded information, he will not be able to perform the operations on that. Why? Because he don't know, he is not the one which is having the key. But in case if he has that particular key, then he can try to decode it, but he will not be having it, because whenever there is a connection formed between two different source and destination, they both will be having those particular keys. Okay, remember that. I hope you people are getting this. So the best example is a WhatsApp group. You people might have seen. If not, you people can see. You can open one of your account number, your friend's number, and there you can see security, and you will see that there it will show you one hologram, and that hologram is the one which is shared between you and your friend. That is unique. Okay, and suppose you are having groups, so group will have a own key. So whenever you're transmitting any message to a particular group, so whoever is present within that group, they will be having the particular key. So okay, we are not using it. By default we are, that is present in the application. The application is designed in such a way that will consist of it, and using that we will be able to see the different messages whatever has been posted in that particular thing. So the only thing what you people have to keep in mind here is something called as keys. Key plays a very vital role. Using this particular key only, we people will be performing encoding of the data. Whatever the data we want to transmit, we can encode it using this particular key. Same way, using these keys only, we will be performing decoding of data. Both will be done. So encoding will be done in the source from where exactly that message has to be transmitted, and decoding will be done at the destination, whoever you have intended to send that particular message. That is what you people have to keep in mind. So here, using these keys, what happens here, it actually enables three different things. Confirmation of a source. So this key will confirm. So whenever you people get a message from the outsider, so suppose your friend, so this will be confirming. This key will confirm, okay, this is from a normal customer. If not, it will immediately give you a alert that this particular person, suppose for example, you don't have a account, a phone number that is present in your mobile phone, and suddenly you got a message from an X person. It will simply say that this person is not available in your mobile. So do you want to save it or you want to delete it? That confirms that particular source. If you don't know that person, what you will do, simply will ask to either delete it or block it. Automatically this application will be blocking it up. But in case if you feel like, okay, you know that person, then what you can do, you can store it. As soon as you are storing that phone number within your system, automatically a key will be generated between your app and between the person who has sent that. In between them there will be a key. Now this key will be shared between by source and destination. So next time if you're transmitting a message or this person is transmitting a message, this key will be used for performing encryption operation. Okay. And the next thing what he's saying is receipt only by certain destination. As I told you, whoever is having the destination key, I mean the key, they only will be able to decode that particular code and they can use access it. So trust relationship between senders. Obviously, if you have that particular key, you people can sending an information from here to here and here to here, source to destination or destination to source. That means you people are trusting each other. You may be sharing some critical information with your best friends or something like that. So what you're doing exactly, you're trusting it that okay, this, so when you're transmitting that message, okay, you're trusting your friend, but you, the way you people are using what kind of application, that is also you have to trust. For example, in WhatsApp, if you people are transmitting the data, so it means, what does that mean? You're trusting that application that whatever the critical information I'm transmitting using this particular application, that will be secured. No one can access that particular data. That's why you people are transmitting it. If someone can hack it or something like that, if the reputation is not good, then will you be using the same application for transmitting the data from that particular application? No, right? So that is what he's talking about in this particular. So these are the three things that enables this particular key. So let's go ahead. So now comes the encryption. So what exactly we are going? So I'm telling you that we will be encoding the data and all. What do you mean by encoding here is nothing but we call it as encryption. So we are going to discuss this encryption here, and then we'll go for the other part. Okay. So here, if you talk about encryption, why we are using this encryption, the best thing is we are using this to send the messages. Like you people are transmitting messages using WhatsApp, normal messages, or your Instagram messages or whatever. So to transmit the message from a particular source to a particular destination, we use this particular technique called as encryption. What it will do is nothing but it is the one which will be performing encoding. It is the one which will encode the data whichever we wanted to transmit it up. So every encryption technique will basically consist of these 3 points. You people have to remember this. It will actually consist these 3 components. What is the first component is a key, as I told you in the beginning, secret key. So it will consist of set of keys. Okay, so it will be consisting of set of secret keys here, and that I'm representing with the capital K. Set. Remember, it is a set. Set means there will be some multiple number of keys. Then we have something called as set of messages. So these are nothing set of messages in the sense we are representing with capital M. So what do you mean by set of message here are nothing but like you people are transmitting hi, how are you? And after that you're in the same message you're typing that be ready by 5 p.m. to go out. Something, this is a message you people are trying to send in a single stretch. So what happens here, these are the set of messages. This hi is one message, how is separate packet, r is separate packet, use a separate packet, this way. So what happens here, each one will be considered as a set of messages here. So that will be represented within the curly braces. That is what he means to say here, messages. Okay, and then we have something called c. C is a term we are using to represent ciphertext. Ciphertext. I don't know how many of you heard this name. Well, ciphertext is nothing but M is nothing but it's a normal message. Normal message. Something like as I told you, hi, hi. So this is a normal message. And once you people are using a key to encode this particular message, you will be getting a ciphertext. Like you may be getting. So hi will be converted into something called as EZ. And oh, let us suppose 0 EZ 0. What do you mean by EZ 0 is nothing but this is high, exclamation mark is represented like this. So this you people will not understand. Why? Because this is an encrypted text. That's what we call it as a C, cipher text. Okay, whenever you people are converting a normal text message into a encoded format, that message is what we are calling it as ciphertext. Normal messages are represented as message, and these are the keys which are used in order to convert a normal message into a cipher text. So in order to do that, definitely we need some function here. So the function what we are going to use here is something like this. We have to use two different functions, one at the source end, another at the destination end. Source end we will be using encryption function, and the destination end we are using something called as a decryption function. So what is the encryption function we are going to use here is nothing but whatever the set of messages we are having here, we will be converting that into a ciphertext messages, set of ciphertext messages. And how we can do that? Using a set of keys that are present into this particular value. Okay, so in this, as I'm telling, this is a set of keys, right? K, capital K represents set of keys. So that keys are represented as small k, K1, K2, K3, so on. What are these small K1, K2, K3? These are the keys, set of keys what we have. So I'm representing with capital. So see here, that is what is representing here. So this is the function we use for encryption. So using a particular key from one of the key from this particular set of keys, we will take one of the message from this particular set of messages, and then we'll that directly convert into one of the cipher text. We'll be directly converting into a cipher text. Now here small k is nothing but belongs to capital K. Now I think you people might have understood what is small k here. This is a small k is nothing but one of the key from this particular set, and ek is nothing but this is a function. Now this whole function, whatever I'm showing here, this he is representing as ek. What is the small k? So using this key, we have used this particular function and we got a new cipher text. Okay, so this is what he's saying here. This is a function. Ek is nothing but it is a function for generating cipher text. For what? For the normal message, whatever you people have typed in your system. Okay, I hope you people are getting it. So here both this key is a normal function, encryption function. Ek means that encryption function you are implementing using one of the key from the set of keys what we are having here. So this is useful. This is sufficiently computable function. So we can easily compute this. That is what he's saying here. Now next is decryption. Decryption process is same. Only thing these two variables will be changing here, vice versa. So decryption means what you have to do. You will be so here when the source person is sending the data, he will be encrypting it and he will be sending it. So when you are encrypting a data, what does that means? It becomes a cipher text. Now that cipher text will be reaching this particular destination. That ciphertext is, but this ciphertext he cannot read. So definitely this ciphertext using the same key which you people have used here to encrypt it, using the same key, they have to convert the ciphertext into a normal text, that is M, and then the destination will be able to read this particular message. So this is the code for that. This is a function we are using. K. So using one of the key from a set of k, I mean set of keys what we have, whatever the ciphertext we have received at the destination will be converted into a normal message. Okay, so at the source end we'll be converting a normal message into a ciphertext using this particular key, and whereas coming to destination we'll be converting a ciphertext into a message using a normal, using that particular key. Same process, remaining both the same what he is talking about here. Okay, so this is the normal technique what we exactly use in order to implement it. So here in this case when we are implementing this, definitely we have a functions and all, right? So there are certain properties that we need to consider when we are implementing it. Yeah. Oh, sorry. So there are some properties that we need to take care when we are implementing this. Let us suppose that your system, your computer is computing a message. Means it is trying to convert this message. You are having some message, something like hi, how are you, whatever it is, so on. This message I am representing with small m. Now this message I want to convert into a ciphertext so that I can transmit that to my destination friend, whoever it is. So here the concept here is how we can represent is ek of small m. So means I am going to apply a function, encryption function. We know that what is an encryption function, using one of the key from a set of keys what we have, and I will be using that key to encrypt this particular message. This is a message, actual message, hi. And this message then finally will be converted into a ciphertext. And then that particular text will be transmitted. This particular ciphertext will be transmitted to the destination. Now here the system, your destination friend, whoever it is, he will be having the same key. This small k will be whatever the key I'm representing here. This key will be present with this particular destination, and this message will be reaching to the destination here. Now what this particular destination will do, he will be applying this particular key onto this particular ciphertext, and then finally he will be able to get the actual message whatever is there, and then he will be able to read the information. And this is a vice versa format. Vice versa means after reading it, definitely if you say hi, they will also respond hi, how are you. So this will be transmitted from here. So when he is transmitting here from destination, he will be encrypting using the same key. Now this time the destination will be encrypting this message and he will be transmitting it. Now since the what we call the you people are, means you being the source node here, you're also having the key. So obviously you people will be able to decrypt that particular code and you will get the information whatever it is, hi, how are you. Then you will be replying it. So every message you people are transmitting over the network is nothing but you people are encoding and transmitting. And how we are doing it? With the help of our technique, we have something called as encryption. Okay. So there are some techniques as I told you. So one among them is symmetric encryption. They're actually okay. Let me show it up and then I'll explain it. So actually, you know what? This encryption is basically classified into two types here. One is what we call it as symmetric encryption. Encryption, and another one is what we call it as asymmetric encryption. This is what we call it as a symmetric encryption, and this is what we call it as asymmetric. Now, the one which we are going to discuss right now here is something called symmetric encryption. Okay, the first one. So what exactly it exactly tells about this particular symmetric encryption is here the same key will be used for encryption and decryption. That is nothing but what I have just previously explained it. So here you are the source node, there is a destination node. He will be transmitting the message. So he will be having some key K. Using that key, whatever the message is there, he will convert into ciphertext and will transmit it. This ciphertext will be received by this particular destination. Now he will also process that particular key. So using this key, applying on the ciphertext, he will get the actual message. What did I also told you that this is a vice versa. So after getting the message, what will exactly happen here is the destination will be giving a reply to this. So when he is giving a reply, he is going to send a message. Now this message will be converted into ciphertext using a key, and then it will be transmitted. Now this source node will be getting a encrypted text here, that is ciphertext. Now this ciphertext will be converted into a normal message using the same key which he is having. So both are sharing this particular key. Since I am telling that this is a single key which is shared by both of you, means the source node and the destination node, both of them are sharing the same key here. So definitely you can understand the importance that this particular key has to be protected. This key should not be known to the third person. If the third person knows about this particular key, automatically he is going to, what is going to do, he is going to automatically decrypt that message, and he will be getting the information whatever you people are transmitting it. And there is a possibility he may try to modify, or he may try to do some kind of infringement with respect to the data whatever you people are transmitting. So that you people have to keep in mind when we are performing it. Now moving ahead, so here apart from this, earlier we, as I told you, that NIST is the organization which actually developed this. So they are the one they used this particular what we call encryption technique. So the most common technique what they used to have is something called as DES algorithm. They use DES, data encryption standard. This is the one which is used in order to convert a normal message into a cipher text message. And this has been used by whom? NIST, National Institute of Standard and Technology. But as you know, the technology has progressed, the hackers are able to detect whatever the message ciphertext is there. This ciphertext message, whatever the actual message is there, they are able to decode it, okay, without having a key also. You know, as a technology getting advanced, automatically they'll have some loopholes, and based on that they used to identify it. So what this particular NIST did is, rather than removing this DS algorithm, since it is of no use in the further, they just tried to modify this particular DS and they have implemented. How did they modify? Here is nothing but the same algorithm they applied 3 times on a particular message. First, what they did, the DS algorithm, they applied only one time. So whatever the message they want to send, they applied using a key one time and they convert it into cipher, and that is transmitted. But now DS, after certain time, they started implementing 3 times. Means first there is a normal message. They applied a key here, they got a ciphertext. Now on this ciphertext, again they applied the same key, they got cipher one. Means much more advanced. And again on that they applied, they used the same key, and again they encrypted this message. Now they finally got C2. Now this C2 will be transmitted to the destination. So in the destination also same process. When he receives C2, he will be applying the key and he will get C1. Again on that particular C1, he will apply the key, and then again he will be getting that actual output. Okay, so whatever the actual message is there, that he is going to get. So 3 times they are going to apply it so that they can get that particular thing operation. Now here how they exactly applied, the question is how they exactly applied this particular thing. Well, they have some techniques here. So the technique what they exactly have here is that they use, suppose you want to send a message, the size of the message they usually used to take something called a 64 bit. Remember this. So first time when they applied only single DS algorithm, when they used to apply it, they used to take 64-bit message. Whatever the message size, suppose if a message size is 128 bits, they will initially take first 64 bits and they will encrypt it. So definitely we have to encrypt it means we need a key. So the key is nothing but that is also nothing but it's a bits. So how many bits they used to bit key is 56-bit key. They used to have a 56-bit key. Using this key, they used to encrypt this particular message. As I told you, you're applying a key, you're getting a ciphertext. So what is the size of this particular message? Whichever we can encrypt is 64-bit. And what is the size of the key? What we can use here is 56-bit. So using a 56-bit, we are able to encrypt a 64-bit message and we'll be converting into a ciphertext. This is the first one we used. And okay, you may be getting, sir, okay, using a key, they are performing this ciphertext. How they are doing it? Okay, so this is a very simple thing. You people will be learning. You people might be learning in your analytics. I mean, for placements, you people will be learning about something like if A, B, C, there will be some mathematics like ABC. I am represent. Okay, sorry, not ABC. Yeah, okay, fine. If ABC is represented as DEF, so how XYZ will be represented? So can you understand this? How exactly people are doing? So you have to find. So A is 1. So D 1, 2, 3, 4, 5, 6 means 1 plus 3 is equal to how much? 4. And this is 2, right? So 2 plus 3 is how much? 5. And C is having a value 3. 3 plus 3 is how much value? 6. Means if I give X, Y, Z, you should know the value of X. So suppose Z is 26, 25, and this is your 26, 25, 24. Then what will be the output? Now can you understand? Can you get that what we call the actual output now? So 24 plus 3. So 24 plus 3 means how much you are going to get? 27. That is nothing but A. Because after we know that in alphabets we have 20 till 26. So after 26, 27 means that is the first letter A. A you're getting. So Y 25. So 25 plus 3, 28. 28 in the sense the second element. So we have in alphabets 26 alphabets. So 26 alphabet is Z. And after that, if you're representing 27 means that is A. 28 means B. So A, B, C. This is actual message. This is the way they used to do. So here what they used is nothing but simple mathematics. That is nothing but we call it as permutation and combinations. This you people might have learned in your school time, in your college. I mean, in either in the intermediate colleges or during their 10th class, normal permutation comp. So using this combination, they actually generate using a 56-bit. They used to convert into a ciphertext a 64-bit message. This is the way they exactly used to do it. I hope you people are getting it. So how exactly they used to do it? Okay. So I will show you one algorithm and then I'll explain it. That then you will understand much more easier. But that will be with respect to asymmetric, not symmetric. Now here, when they applied for 3 times, like for example, as I told you that they used to apply 3 times here. This is the function they used. So to get a ciphertext, they used to use encryption function where they applied 3 different keys. So what are the 3 different keys? So what is the 3 times they have performed? That means what does that mean is 2 times they used to perform encryption. 2 times they used to perform encryption and 1 time they used to perform decryption. Okay. So triple, this is what we call it as triple DES. Triple DS is nothing but 2 times they used to apply encryption and 1 time they used to apply decryption. And that is what you're doing. So first time I'm encrypting it using a key number 3. Then using a key number 2, I will decrypt it. And then using again next key number 1, I'll again encrypt. So this is the formula what we exactly have. So what we are doing is this is the actual message. So this message I'm going to encrypt it using the first key. And after encrypting it, I'll be getting a ciphertext. That ciphertext I will be decrypting using this particular K2. Definitely I'll be getting not the actual message, some other message, because I'm using the second key, not the first key. If I use the first key, then definitely I'll get this particular message, but I'm using a separate key here. So definitely you'll be getting another cipher, that is C2. And on that C2, you'll be applying this particular EK3, that is encryption using this particular K3. So finally you'll be getting a ciphertext something called a C3, and this C3 will be transmitted to your destination. So it becomes very difficult for them to understand. Means the in between hackers or man in the middle attack, what we have seen in the previous session, they will not be able to know exactly what the message it consists of, because they don't have three different keys. Earlier there used to be only single key. Somehow they used to manage to get the particular key and they used to decrypt it. But now since you people are using three different keys here, definitely they should have three different keys. Then only they will be able to get the actual message, and definitely they will not be able to be successful in getting that. So they will be not able to do that. But when they applied this triple DES, what happened here is the number of keys. Earlier, what is that? When single time we used to apply this particular DS means how? What is the size of this? 56-bit key we used to use it, right? But now this has been transmitted to 128, 192. So we have three different type of keys now. First time 128-bit. Next, you people can use 192-bit. Then we can use 256-bit. And I'm telling you that when you are using such a high, see where is 56 and where is 128. So when you use 128, it becomes very, very difficult for you people, and the what we call the system to detect, or the hackers to detect the actual output. And that's the reason, that is what I showed you in the beginning. Now, how strong is your password? So what exactly you're doing? So when you give a password, something like XYZ at the rate 123, for this will be applied. The DS algorithm will be applied. So it may be a 128-bit or it may be a 192-bit. So based on that, what will happen? This XYZ at the rate 123 will be converted into a different format. Different format means it will be something very big message. And this big message for a hacker to crack will take a lot of time. And that you people have seen it, right? Some trillions of years, some billions of years. If you give only normal password, something like your phone number, your date of birth, it may take only 50 seconds to crack them, or something like you have already seen it, right? So I'll tell you once again later on, whenever we have a free time, I'll tell you so that you people can understand. So this is what comes under into this. So triple DS, you remember? So if you are applying DS for the only one time, so we are using a 56-bit key. And whereas coming to message, we can use 64-bit message. But when you are applying triple DS, okay, triple DS, advanced encryption standards, when they have applied it, then what happened? The key size has been increased. Not only key size, even the message size. Earlier it is 64-bit. Now they have increased it to 128-bit. And if you see the key size can be 128-bit, or it can be 192-bit, or it can be 256 bits. It's very, very difficult to crack the code. Whatever the ciphertext we are having, it's very difficult to crack it and get the actual message because of these particular keys. And later on, we had one more thing. See, implementing this is also typical thing. So definitely for that, we have stream ciphers. Then came stream ciphers into picture. So what is stream ciphers are nothing but these are used to encrypt a stream of bytes or bits. Means rather than taking a block, like as I told you, that we are using 64-bit block. Means 64-bit message. That message is what we call it as a block. Suppose you are having a 25 bits, 128 bits message. So what happens here? 64-bit will be taken first among this, and that message will be converted into ciphertext. Then after that, the remaining 64-bit will be taken, and that message will be converted into ciphertext. But what exactly you're doing? This 64-bit he is talking about as one block. So it means if you are having a message of 128-bit message, this will be converted into two blocks. Okay, so the first block will consist of 64-bit, and next 64-bit will be present in this particular. So this will be converted into ciphertext C1, this will be converted into ciphertext C2, and both this will be transmitted one after another. But what happens here, blocks means it becomes somewhat typical, and implementing them is also very, very tedious task. So in order to overcome this, what they did is they came up with something called as stream ciphers. Stream ciphers, what they do is rather than taking the blocks, that is nothing but bits, they used to take bytes. They can use either bits or bytes. Okay, and using these bits and bytes, they used to encrypt it into convert it. I mean, they used to convert that into ciphertext and transmit it. So for that, RC4 is one among them. RC4 is the most common stream cipher. What we use it, symmetric stream cipher, we use it up. Okay. So here, what exactly they are doing is they use something called a pseudo random generator. Yeah, this is represented. This is the one which they used. They use this particular technique, something called a pseudo random bit generator. This is a generator. I mean, this is a kind of an app they used to use it, and within this, a key is given. Whatever the key we are using, 56-bit or 128-bit or whatever it is, that is given to this. Now, what this generator will do, he will be generating some stream of bits. He will be generating some stream of bits, and that bits will be like, infinite key stream. We call it as in, means very large. For example, if you are giving a 120, 256 bit, this will be converted into some 1026 bit size. So you can see 256 bit key is converted into 1026 bit key. That is very, very big. Okay, so that is what he's saying, generates an infinite key stream, and this stream is applied to the message, and then it is converted into a ciphertext and it is transmitted. So it becomes much more difficult for the hacker to overcome this particular thing. So this is what the diagrammatic representation in order to do that. See here, the user, this is the user, and this is the sorry, this is the sender, and this is the receiver. Now sender, what he did, he simply wrote a message here, normal M message. And what is this message here? We call it as a plain text message. Normal message is nothing but plain text, nothing but you people are writing hi. So this is a plain text message. That text message you people are giving to an encryption algorithm within your system based upon the application you are using, and that encryption will be performed. How that encryption is performed? As I told you that there will be an encryption key. So this key will be given to this particular algorithm and this. So you may be wondering, okay, sir, where exactly we are doing? Well, this is done by your application. For example, if you're using WhatsApp here and you're transmitting hi to your friend, so WhatsApp will be performing this encryption. That's the reason we will not be seeing it. So WhatsApp, what it will do, it will automatically encrypt. So WhatsApp application consists of an encryption algorithm and key. What is the key here? As I told you, in between the sender and the user, between you and your friend, there is a code, histogram code. That code is what used as a key, and that is what is being given to this particular algorithm. And this will be converting your normal plain text message into a ciphertext, and then it will be transmitted. Now, if you see, there is a attacker here, hacker, the cracker. He's trying to get. So whenever he try to hack the information when you're transmitting over the network, he will be receiving this message. What is the message here? Ciphertext. Encoded message will be received, but this particular hacker will not have your key, this key, because this key is with respect to the sender as well as the receiver. This person will not have that key. So what is the message he will receive is the encoded message, and he will not be able to decode it. Fine, that's no big deal. Automatically people can remove it up, so he will not be able to hack it up. So finally this message will be reaching to this person also. So what is the person here? Receiver. He will be having the key. Now that key he will give it. So so the WhatsApp application of this particular receiver will be performing decryption, and finally a plain text message will come, and this message will be read by you people. So you will be ultimately getting a message hi. Now what happens here is you will be transmitting a message, right? You got a hi here, so definitely you'll be responding something like hi after a long time. After a long time you're transmitting. Now what happens here? So this particular receiver, whatever the message he's sending here, now here the same key is used to convert this into a ciphertext, and that ciphertext will be transmitted here. Same way this sender will be giving a key, that ciphertext message will be again converted into a plain message, and this particular plain message will be read by this particular sender. Remember, okay, so when this person is sending, earlier what did I say? He's the sender, he is the receiver, but when he is sending the message, he becomes the sender and this becomes a receiver. This is a vice versa kind of a format what we are representing here. Okay, so I hope you people are getting it. So okay, fine. So we'll stop here. In the next session we'll be discussing about asymmetric key. This is something important, and on this we'll be working some problems also, so that you people get something more benefit related to this. You people can understand. Yeah, this is a formula we are having here. You can see here, these are the formulas we have. So here you can see these are the formulas what we are exactly using here. This one. So I will explain in the next session, and we'll be doing some problems with respect to that. These are very easy and interesting. Yeah, there is an example also here. Here, this example will discuss it. And with this, once we complete this asymmetric key and authentication is there, and here we'll be using some related to that, and finally we'll be completing this particular unit. Okay, so I hope you people have understood this particular concept, and if you have any doubts in this, you people can just ping me up. Thank you for watching.